Hello all, welcome to another session of learning algorithms. In today's session, we will be learning another new algorithm. And today's is going to be finding the square root of a given number. So this problem statement tells us that given a number m, design an algorithm to calculate its square root. So very simple, any number if we are given, for example, if at all it's given 4, we have to find the square root, and obviously we know that the square root is 2. So how to determine this value is what is this algorithm is all about. Okay, so let us go ahead and see how can we do that. Now a square root of a number is a value when multiplied by itself gives the number. Okay, so in most of the programming language, we will be having a built-in functions in order to find out the square root of any number. For example, you would have seen SQRT, square root of any n value. If you give, it will get us the square root of that number. But if at all I have to write a logic for that, how can I do it? That is what we would be learning today. All right. So the very first thing is we have to understand that a square root of a given number. Example, if at all 2 I have, when I multiply it with 2, I will get 4. Okay, so now when I find out the square root of 4, I know that it is 2. It is as simple as that. So if I say 3 into 3, it is nothing but 9, and square root of 9 is nothing but 3. So what you understand by this is, whenever we have to find a square root of number, the whatever value which gets generated, it is nothing but when I multiply the same number with itself, that is when I will get the original number. So that is what is the meaning of this statement. A square root of a number is a value that when multiplied by itself gives the number. Okay, so it is a value when it is multiplied by itself gives me the value. So in simple terms, I can write it as n into n is equals to m, where square root of m is nothing but n. Okay, so with this understanding, let us go ahead and try to find out how to check the square root of a given number. So there are many methods. In today's session, we will be looking into Newton's methods to find the square root of a number. So this basically works on the principle of guessing the number. So let me give you one example before we get on to the algorithm directly. Suppose I have to find out the square root of 6. Okay, so now I know that any number when I multiply it, I'll get the original number. If at all I'm taking 6 or 3. So when I say 3 into 3, it is 9. Now this value is higher than 6. So let me take 2, which is less than 3. So I will take 2 into 2. Once again, it is 4. And this value is greater than 4. So the value, the square root of 6 must be lying between 3 and 2. So what I will do, let me take 2.5. So when I say 2.5, if I'm guessing, 2.5 into 2.5 is nothing but 5. Once again, it is less than square root of 6. So it must be less than 2.5. So let me take 2.4. So if I say 2.4 into 2.4, what is the value I'm going to get? So if you multiply 2.4 into 2.4, you will end up getting 5.76. Okay, 5.76 is yet again, it is less than 6. Now let me just slightly increase the value, that is 2.45 into 2.45, which is nothing but 6.0025. Okay, and it is once again higher than 6. Let me just make it a bit smaller, that is 2.449 into 2.449. So when you multiply this, you will get the value 5.997601. Once again, this is less than 6, which means once again the value must be lying between somewhere between these two. So let me slightly make it a bit lesser, that is 2. Since this is lesser, which means I have to increase the value. So 2.44 instead of 9, I will say 93. Okay, so when I say 4.993, I will get 5.999. So I will get 5.99907. Once again, this is less than 6. Let me increase one value This let me increase. So I will say 4494. So when I multiply this with another 2.44494, I will get 5.999560. Okay. So once again, it is little less. So let me just increase a bit by 2.44945. If I put, when I multiply that, I will get 5.99980. Okay, now this is much better compared to all these values. So I can take that square root of 6 is 2.44945. So if you want it to be more closer, you can further increase the value, decrease the value, and check. Now, what exactly we did here, we are doing here is we are trying to guess the value. So initially we started with the broader values 3 and 2, and we realized that the value must be lying between these two. Then we took a 1 decimal value, then we took the 2 decimal value, 3 decimal, 4 decimal. So this is how we are doing the guessing. Now this is on this basis itself, the Newton's way of finding a square root of any number exists. Okay, but yeah, the guessing work remains same, but there we also have a formula. So let us go ahead and see what exactly is that formula tells us. So in Newton's methods to find a square root of a number, we have a formula which says root, that is a square root, whatever you want to find out, is equal to 0.5 into n plus m by n. Now, what are these n and m? M is nothing but a given number. In our example, we were supposed to find the square root of 6. So value of m was 6. Now, L is a tolerance level. Now, what is this tolerance level? So when I was calculating, I was telling you that it is 5.99906 and 5.9999. Now, when difference between this is over here, that is a tolerance level. How much closer you want your value is nothing but the tolerance level. And what is N? N is any guess. We did the guess, that is, it could be 2, it could be 3, it could be 2.4, 2.45, 454, 3, 9, etc. All these guesses, whatever we are doing, we will be applying it over here. That is at N. Okay, so this is how the formula works. So let us go ahead and see the algorithm first, then we will iterate this with the help of an example. So we will declare the variables m, n, and l. So we will know the value of m, that is the square root of whose square root we are supposed to find out. Then we will also guess the value n, and we will also know the tolerance level, that up to what is the difference between the actual value and the root we want. Okay, then we will initialize root to 0. The root value will be initially 0. Then set initial guess n is equal to m by 2. So here we are saying that n is equal to m by 2. Directly we will take the half value of the actual value whose square root we want to find out. Then repeat the following step until the absolute difference between n and the root is less than the tolerance limit. So the difference between n and root, that root value, whatever we are calculating, until we will get it less than L. Okay, until we are going to repeat this loop, and then we will apply the formula. So if it is not less than the tolerance level, then what we are going to do is, as soon as we guessed, initially we have guessed m by 2, then I will change the value of n to whatever the root value I have calculated. So in that way, we are going to reduce, and then we will print the root. We will look into one example, then that time it will be clear. Okay, so let me find the square root of a number 256 using Newton's method. Okay, so we know that m is 256 here, n is 256 by 2, that is nothing but 128. And then let me take a tolerance level is 0.1. That is, I do not want the difference between my guessed value, that is guessed root, as well as the root to be less than 0.1. Okay, so this is how we will start. So let us start the first iteration, where I will say that root is equals to, I'm applying the formula 0.5 into, so n value is nothing but 128 plus 256 divided by 128. Okay, so 0.5 into, this is nothing but, here you will get the value 2, 2 plus 128 is 130. So 0.5 into 130 will get us 65. Now the root value is 65. So if you see 65, when I compare with 65 and 128, the difference is not less than 0.1. There is a huge difference. Hence, I will iterate further. So now my value of n will change to the whatever the value we have calculated as root. So now root is nothing, the n value is nothing but 65. So once again, we will calculate root is equal to 0.5 into 65 plus 256 divided by 65. So 0.5 into, when I calculate all this, I will get the value 3.93. Okay, so in turn, I'm going to get the value 65, sorry, this is 3.93 plus 65 will give me 68.93. So 68.93 into 0.5 will give me 34.46. This is the root value. And what is my n value? N value is 65. Once again, there is a huge difference. Hence, for the third iteration, I will change the value of n. Now, n will become the root value. So, root is equals to 0.5. The n value has changed to 34.46 plus 256 divided by 34.46, which is nothing but 0.5. So this entire value, when I calculate, I'm going to get 7.42. So 7.42 into 34.46 will generate 0.5 into 41.88, which is nothing but 20.94. This is my new root value. And my n value was 30.46. Now, once again, there is a difference which is more than 0.1. Hence, I have to move on to the fourth iteration. So, once again, root is equals to 0.5 into, now my n value is going to be 20.94 plus 256 divided by 20.94. Okay, so when you calculate this, you are going to get 12.22 plus 20.94 is nothing but 0.5 into 33.16. Little variation here, so I'm going to get 16.58. Again, there is a more than 4-point difference. Hence, I'm going to go to the fifth iteration. I will say r is equal to 0.5. My new n value is the root value of the previous iteration, which is nothing but 16.56 plus 256 divided by 16.56. When you calculate this, you're going to get, you will get around 15.44. Okay, when you add it, you will get 0.5 into 32.02, which is nothing but 16.01. Okay, but still here, now if you subtract 16.56 with 16.01, the difference is more than 0.1, which is our tolerance level. We are almost close. So let us do the last iteration, where I'm going to say r is equals to 0.5 into 16.01 multiplied by 256 divided by 16.01. When you calculate this, you will end up getting 15.99, which is nothing but 0.5 into 32. You will be getting 16. Okay, now the difference between 16.01 and 16 is nothing but 0.01, which is of course less than our tolerance level. Hence, I can say that the square root of 256 is 16. As simple as that. Okay, I hope though this session has been a lengthy one, it is a very simple example until you know the formula and how to apply it. It's a very simple one and easily understandable. All right. So that's all in today's session, students. If there is any doubts in this particular session, kindly write it in the comment box. I will reply. Thank you for watching. Keep learning.